The headline of the article is "The use of finite element method technology in the analysis of the stability of the design concept of a residential building floor of life in conditions of explosive loads." The article is written by Oleg Chernih, Oleg Sokolenko, Kostiantyn Sokolenko, and Mykyta Sadkovsky. Aggressive neighbors are not chosen. Our country has been living and fighting against the aggressive influences of its northern neighbor for a long time. There is a process of constant destruction of buildings and structures. In many cases, the damage to civilian objects is of a progressive nature. For example, the state of buildings in the cities of Borodyanka and Severodonetsk. In order to restore the affected regions of Ukraine, it is necessary to start developing new conceptual approaches in the field of construction, in particular in the construction of residential buildings with increased resistance to progressive destructions that can be provoked by explosive impacts. The emergence of the topic of progressive collapse is associated with a number of tragic events, which have in common the factor of disproportionality between the emergency event and the amount of final damage. The accumulated experience in the form of destruction of buildings and structures during the war, when civilian construction objects are subjected to systematic shelling and brought to the stage of final destruction. Panel houses from a domestic gas explosions and single terrorist explosion is quite different from the experience of progressive destruction. The rear supports of fair package implement the progressive destruction system, which meets the existing recommendation for modeling the behavior of structures of buildings in the event of emergency impacts that cause localized destruction of individual supports. Involvement of centuries of historical experience in construction can lead architects and engineers to create reliable structures. The proposed conceptual model of a monolithic reinforced concrete building is characterized by increased rigidity compared to the most common monolithic buildings with a free layout, especially panel buildings. However, safety requires additional cost. In the Sophia preprocessor, a finite element model with applied loads was created based on the BIM model of the building. The basis for the volumetric spatial scheme of the building is the principle of double walls. That is, the creation of living quarters is located behind at least two load-bearing reinforced concrete walls. The load-bearing elements of the building are round-shaped reinforced concrete walls inscribed in a circle and arranged in such a way that they intersect each other. The calculation of the residential building model was performed in a non-linear formulation in a step-by-step mode, taking into account the real diagrams of concrete and reinforcement in the montage system of the rear supports of fair package for static loads. 4 finite element models of the building were analyzed, 1 original model without damage, and 3 models with the most stressed elements sequentially dismantled. The creation of new models was completed after reaching the stage of destruction of the finite elements, it is, after the start of the progressive destruction process. The main results of the calculations are shown in Table 1. As a result of the modeling of the stress-strain state of building structures for monolithic reinforced concrete residential block under shelling using finite element method technology in a nonlinear formulation, it was found that the proposed conceptual model of the building allows avoiding progressive destruction even in the process of successive shell hits to the most stressed areas of the bearing structure. The analysis of the results of finite element model calculation shows the following. The proposed volumetric spatial scheme of the building allows avoiding progressive destruction of the building as a whole, even with the sequential destruction of 3 load-bearing walls. We have the opportunity to ensure the safety of the inhabitants of such residential building in the event of repeated hostilities with artillery shelling. Of course, residential buildings of this type are more expensive than modern ones. 2 floors for bomb shelter, double and triple protective external reinforced concrete walls, increased consumption of reinforcement and concrete. But we already have practical, numerous and quite tragic experience of the destruction of our city and towns. Therefore, we consider it appropriate to reduce such construction at least when rebuilding border towns to ensure the safety of possible accommodation. This type of construction, unfortunately, will be relevant for quite some time. The period of successful implementation of the billboard in the Scandinavian countries took 50 years, and there is no hope that there will not be a next invasion. Therefore, it is necessary to rebuild reliable residential buildings to ensure their resistance to progressive destruction. Thank you so much for your interest and attention.